Being exposed to a laser beam can be hazardous when viewing it directly or when viewing a beam from a reflected surface. This module will discuss laser beam reflection types and what the potential for injury is. When light strikes a surface, some or all of it may be reflected, and the reflected rays will satisfy the law of reflection. Angle of incidence equals the angle of reflection. Reflections that occur at mirror-like surfaces produce specular reflections. Accidental eye or skin exposure from a Class 3B or 4 laser to specular reflections can be as hazardous as a direct exposure, also known as intrabeam exposure. While the beam direction may have changed, properties such as divergence, diameter, and power density may not have been altered. Diffuse light reflections occur when light strikes rough surfaces like roadways, cinder block, matte-finished instruments, or walls with surface irregularities that are randomly oriented. At a microscopic level, light reflections from these rough surfaces still satisfy the law of reflection. However, the numerous irregularities scatter light in all directions. Diffuse light reflections present a lower potential for ocular injury because the eye absorbs or is exposed to a smaller portion of the overall light. This is also true for skin exposures. Light reflections are not inherently hazardous and are usually the intended outcome of directing or manipulating laser energy. Laser light reflections become hazardous when they are unintentionally or accidentally directed at eyes or exposed skin at power or energy density levels that can cause irreversible injury. These would be levels greater than the maximum permissible exposure, also known as the MPE. The goal when working with laser light is to recognize the potential for reflective hazards and implement proactive control measures to minimize their potential for causing injury. Proper selection of protective eyewear is also necessary to safely attenuate or reduce potential reflections to levels safely below the MPE.